All right, how's it going, everyone? Thanks for watching this video. Again, please make sure you hit the like button at the bottom of this video. That would be greatly appreciated. Um, this video, of course, is looking at adding and subtracting fractions and mixed numbers with like denominators, also known as the same denominator. This is kind of a continuation of a previous video, so if you need to, you can go back and watch my previous video, which was adding and subtracting fractions with like denominators. Of course, we have our Common Core standard NC5 NF1. That's a North Carolina Common Core standard for 5th grade for adding and subtracting fractions and mixed numbers. However, that is with unlike denominators. But we're going to take a step back and look at solving it with like denominators or the same denominator and looking at word problems. Do keep in mind you can pause this video at any time so you can write down any information and solve any of the questions that will be given. Just some key things to remember. A fraction, of course, is part of a whole. You have different kinds of fractions. You have a proper fraction, which is where the numerator is smaller than the denominator. And an example of a proper fraction would also be another name of a proper fraction, and that's a unit fraction. That is where the numerator has a 1 as its numerator, and the denominator, of course, can be any given number. As you see from the screen, these here are unit fractions, but they're also proper fractions. Then you have something else called an improper fraction, and that is where the numerator is larger than the denominator. So let's go ahead and take a look at some adding and subtracting fractions and mixed numbers, but definitely within some word problems. And I'm going to be using the screen. Also, by the way, I'm using something called brainingcamp.com. It's a great resource. It has manipulatives that you can use, such as these number tiles. And of course, as you see on the screen, it looks like it's a smartboard as well that can be used. So it's pretty cool. So that's what I'll be using to help solve the problems. All right, so let's take a look at a couple word problems here. Of course, while this loads. And keeping in mind, as I mentioned, you can feel free to pause this video at any given time so you are able to solve any of these questions on your own. That would be great. But let's take a look at this first word problem. It says there were 3.5 bags of flour in the kitchen. A little typo there, but 3.5 bags of flour in the kitchen. 4.5 bags of flour were delivered. How many bags of flour are there in total? So here, of course, with any word problem, you should take information out instead of just reading the word problem straight through. So we see that there is 3.5 bags of flour in the kitchen. So if I were to go here, I want to, of course, clear this out. And I'm going to write that 3.5 bags of, I'm just going to put bags for short. So 3.5 bags of flour, that's what they already had. And of course, going back to the question, 4.5 bags of flour were delivered. So they received an additional, well, that looks like a multiplication sign. Let me just erase that there. Again, see, really cool with this program. So plus, and it said 4.5 bags were delivered. So they got 4.5 more bags. All right. So again, forgive the writing. It's pretty hard writing with the mouse, but nonetheless, you get that. You understand there. So let me just put that down. So we have 3.5 bags that they had in the kitchen, and they received 4.5 more bags. Now, when it comes to adding mixed numbers, anytime you have a mixed number, which is a whole number and a fraction together, if the denominators, of course, are the same, you can go ahead and add them. When we look at mixed numbers with different denominators, which will be, of course, another video, a little bit more work is needed for that. But with this case, we can go right ahead and solve this. You can do one of two things. You can convert the mixed number to make it an improper fraction and then solve it that way. Or because we're adding, we can, in a way, take the whole numbers, put them to the side for a bit, and work with the fractions. So again, I can use manipulatives here. So if I say I have 3.5 bags, so that's 1, 2, and of course 3. All right, that's 3. And then we have a half. So 3.5 bags. And then we have got 4 more. So 1, 2, 3, and 4. I got 4.5 more. All right, so right away, what I was saying is you could take the holes, kind of move them to the side, and work with just the fractions in itself. But in case you didn't know, let me just take this one right here, move it here. Anytime you have half, you would need another half to then make one whole. So that being said, if we have 2 halves here, we could say that would be equivalent to 1 whole. So if we add that 1 whole to these holes that we have, 1, 2, 3, 4, 5, 6, 7, plus the 1, we would end up with 8. And the answer, of course, for this problem, how many bags of flour are there in total? There's a total of 8 bags of flour. All right, let's take a look at another problem here. Sean did 1 2/5 loads of laundry on Friday and did another 1 4/5 loads of laundry on Saturday. On Sunday, he did another 1 1/5 loads of laundry. How many loads of laundry did he do in total? So let's clear all this. And we see here, again, I like to take out the information. So we see from this problem, it has Friday, Saturday, Sunday. So I'm going to take out that information. So Friday, I'm just going to put F, Friday, Saturday, and then I'm going to put S, U for Sunday. So again, just taking out this information is key. So on Friday, he did 1 2/5. So 1 2/5. All right, that's what he did. And did another 1 4/5 on Saturday. So 1 4/5. Forgive that, that's a 5. And then, of course, on Sunday, he did another 1 1/5. 1 1/5. All right. So right away, we can see that we have 1 whole, 2, 3. So we have 3 holes there. And then we, of course, got to work with a fraction, or fractions, rather. So anytime it's saying, of course, these were, he had something, he did more, and then he did more of something else, well, then the question we're asking is, how many loads of laundry did he do in total? So we then need to add all of these up. All right. So again, if I were to use some manipulatives, so there's 1, there's 1, and there's 1, and he did 2/5. So I'm going to come down here and find fifths. I'll put that up here. And then here's 4/5. 1, 2. Link those with that. 1, 2, 3, 4. And then here is another 5th. So that one I think went over there. So let's just bring one there. There we go. All right. So we have 3 holes here, 2/5 along with that, 4/5 with this hole, and 1/5. So if we're adding this, we can see, well, how many fifths do we have? Let's take the fractions. 1, 2, 3, 4, 5. Well, 5/5 equal 1 whole. 1, 2. So right here I end up with, let me bring this down here so you can see good representation. If I were to take these 1, 2, 3, 4, and 5, I see I get 1 whole, and I'm left with 2/5 here. So if I add the 1 whole to those 3 that I already had, I see 1, 2, 3, 4. I get, well, let me just get my marker here. 4 is a whole number, and 2/5 remaining. And of course, my answer, how many loads of laundry did he do in total? The answer, of course, would be 4 2/5. Again, it's so great to use manipulatives. It's very helpful. If you don't want to just go ahead and do pencil and paper, use manipulatives. And you can even create manipulatives on your own. You can cut out pieces of paper, fold it, label it. It's a great tool. All right, let's do one more. Sean ordered 2 pizzas on Friday. On Friday night, he finished 7/8 of a pizza for dinner. He put away the pizza and planned to have another 3/8 of a pizza on Saturday for lunch. How much pizza was put away after Friday's dinner? All right, so very wordy here, but we can still go ahead and solve this. So let's clear this out. So it said Sean ordered 2 pizzas on Friday. All right, so let's take that, 2 pizzas. Let's just use the manipulatives now. So we're going to say those are 2 holes. That's representing the pizza. All right, okay, so 2 pizzas. That's how many he ordered. On Friday night, he finished 7/8 of a pizza. So on Friday, he had 7/8 of a pizza. Well, we can stop here and try to figure this out. If he had 7/8 of pizza, or he ate 7/8 of pizza, there has to be a certain amount that is, in a way, remaining. So that being said, if we were to take, let me put my marker away. If we were to take one of these holes, right, that's a whole pizza, and we have eighths. So let's put the eighths here. 1, 2, 3, 4, 5. Oh, didn't do it. 5, 6, 7. Don't know where it's going, but here's 7. Okay. 1, 2, 3, 4, 5, 6, 7. So 7/8. That's how much he ate of this one whole pizza. So how many would you think would be remaining? If you said 1/8 would be needed, let's see. Well, you're absolutely correct. So that we know is what's remaining from this hole. So this is done. That whole pie is basically gone. So let's move those down here. We don't need those anymore. All right, he ate 7/8. Oh, better yet, yeah, let me X out of them. Again, that's a cool option. I could just X out of these so we don't need them anymore. So it's not confusing. There we go. So we know 1/8 is remaining. Okay, and we still have this other whole pie here. So let's go back. He ordered 2 pizzas. Okay, we got that. On Friday night, he finished 7/8. He put away the pizza and planned to have another 3/8 of pizza on Saturday. So which means he took this whole pie that was remaining along with this 1/8 from this pie, and he put that away. So now Saturday, if I get my other marker here, Saturday, it said he planned to have another 3/8 of pizza on Saturday for lunch. Okay, cool. How much pizza was put away after Friday? So really, if you think about it, do we really need to figure out the Saturday portion? Not necessarily, because it says he planned to have another. So it didn't say that he actually did have it, but he was planning to have it after he put it away. How much pizza was put away after Friday's dinner? The answer, of course, is 1 1/8. That is how much pizza he put away. 1 1/8 pizza, and we see it there. Again, using manipulatives is a great tool. All right, so now I want you to, of course, pause this video and practice these on your own. So once this load again, as I mentioned, please feel free, pause this video at any given time so you can practice this. But here are 2 problems I want you to practice on your own. So pause this video and we'll go from there. The first question is, Mrs. Bloom, or Miss Bloom, had 4 7/12 boxes of pencils, but 2 1/12 boxes of the pencils were broken. After she threw out the broken pencils, how many boxes of pencils were left? All right, so pause the video and try to figure that out. All right, well, hopefully you were able to pause this video and try to work this problem out. Again, Miss Bloom had 4 7/12 boxes of pencils, so that's what she had, but 2 1/12 boxes of the pencils were broken. after she threw out the broken pencils, so she got rid of them, how many boxes of pencils were now left? That, of course, means you must subtract. So if we have 4 and 7/12, write it here, 4 and 7/12 minus 2, let's go back and make sure, 2 and 1/12. Hopefully you set up your problem like that. And the answer you, of course, should get is 2, and 7 minus 1 is 6. We keep the denominators the same. 2 and 1/12. And if anybody, of course, went the extra step and simplified, this would be 2 and a half. So 2 and a half boxes of pencils were left. Hopefully you got that answer. All right, again, pause the video after I read this, and then we'll solve this problem. On Friday, many of the students were missing in her class. 1/8 of the class went to a basketball tournament, and 1/8 of the class called in sick. What fraction of the class was in school? All right, so pause the video, think about it first a little bit. All right, hopefully you were able to pause the video and come up with an answer. The answer, of course, is 6/8, which, of course, can be simplified to 3/4. How do you get that? Well, again, let's go back and read it. On Friday, many of the students were missing in her class. 1/8 of the class went to a basketball tournament, and 1/8 of the class called in sick. So which means this fraction and this fraction, they were not there. And the question they're asking is what fraction of the class was in school or was there? So we got to figure that out. Well, 1/8, again, let's clear this out. 1/8 plus 1/8 is, of course, you guessed it, 2/8. So if 2/8 of the class, let's go back to our question, if 2/8 of the class were not there, what fraction of the class was there? So what you do with this, how many more eighths would you need to make a whole? So again, if I have 2/8, 1, 2, and let's take my whole, I need a whole class here. How many eighths would I need to make one whole? Well, let's see. And let's bring you down here. That's 1, 2, 3, 4, 5, 6. So we needed 6 more eighths to make up the entire class. And that is how you got 6/8, which again can be simplified to 3/4. I hope you enjoyed this video. Again, please make sure you hit the like button. That'd be greatly appreciated. And stay tuned for more videos. All right? Take care.